All right, good morning, everyone. I'm really excited to welcome you all today to the final Innovator Showcase Series of 2020, and it's a very special one for us today. So not only are we featuring a really terrific topic, digital solutions for water, easier to smarter, all things that sound like stuff we need much more of in 2020. But we're also featuring 4 very special partners to Current, a couple of our startup partners, one of our technical advisors, and a company that has grown right out of one of our major utilities right here in our region. And so we're very excited to feature these companies today and to be back for a final showcase of 2020 with our key programmatic partner, ChicagoNEXT, an initiative of World Business Chicago. So just a few housekeeping items as we get started. If you've never been to an Innovator Showcase before, welcome. We're so excited you're here. This is an event where we really want to have a lot of questions and Q&A going in the chat tab. So please put your questions in at any point for any presenter. We will be building in Q&A for each one of our 4 showcase presenters during, right after their presentation, but we may also have time at the end to get a conversation going among them. So put your questions in, don't be shy. We want to hear from you. We want to hear what's on your mind, and so do our presenters today. This event is being recorded, and the recording is going to be posted to our YouTube channel after the event. So if you have to step out or can't stay for the whole thing, don't worry, you'll be able to go back later and see everybody's presentation. Really quickly, our agenda, we have very short intros from our co-presenters, and then we're gonna get straight to the innovators themselves. So we're gonna hear from Chris Sosnowski, the founding CEO of Waterly. Chris is also one of Current's strategic advisors, and we're really grateful to have him here today. From Guy Meiri at IOSight, he's the head of business development there, a partner to Current in so many ways, including on one of our major pilot initiatives, H2 Now Chicago. Patrick Kiely, the CEO of SENTRY, another of our key startup partners. And finally, Lev Goldberg, the CEO of Aquify, which is an Exelon company. We'll have group Q&A and then just a few closing remarks highlighting some events coming up in 2020. So just a few words about Current. Again, if you've never joined an event with Current and today is your first, Current is Chicago's water innovation hub. So we're headquartered here, but we're an unbiased advocate for the best water solutions and policies wherever we need them. We try to stay on top of the latest in water tech. We know this field changes so fast, and that's why we're here today with the Innovator Showcase, to show you just a few of the ideas that are coming up and really helping us understand how to manage pressing water challenges more effectively. We also provide independent assessment of technology. So through techno-economic analysis and sourcing and de-risking technologies, we try to help match solutions with end users. And finally, we recommend solutions for others to try or occasionally for us to pilot. So we really try to bring technology from bench to market and from idea to real world setting. That's what Current is all about. And we're excited to be here today talking about digital water and all of the different solutions that can be applied to solve a range of challenges in water using digital technologies. And now I'm really excited to turn it over to our co-host today, Eben Kyriakos, who leads up ChicagoNEXT. Eben, over to you.
Thank you, Elena, and thank you, Current, for inviting ChicagoNEXT to be a partner for these Innovator Showcase Series. They've been incredibly important, especially in the, during this COVID environment, to have these virtual events to convene entrepreneurs and the local community to really kind of showcase the incredible innovative solutions by these startups. Again, my name is Eben Kyriakos. I'm the director of ChicagoNEXT at World Business Chicago. World Business Chicago is the City of Chicago's economic development organization chaired by the mayor, and ChicagoNEXT is WBC's dedicated initiative to grow our local tech economy and support our local innovation ecosystem. If I had more time, I would love to do a full presentation about why Chicago continues to lead as a global city for technology, innovation, and entrepreneurship when it comes to our thriving startup ecosystem, our growing VC totals every year, the number of innovation hubs here in our city, access to world-class universities and national laboratories. We have so many of the key ingredients for a very healthy and thriving innovation ecosystem. And we're incredibly proud to convene a wide variety of tech community leaders from the larger institutions to the smaller startups and medium-sized companies to make sure we're all going in the right direction for tech economy growth. The two things I want to highlight when we talk about COVID, especially in 2020, and how we've been responsive to the needs of the tech community during COVID, has been Think Chicago. There's been a collapse of on-campus, in-person recruitment And for a lot of tech companies and startups that were seeking top-tier talent, we really stepped in with a series of virtual programming. So if you want to learn more, go to www.thinkchicago.net. That's where you can learn more about our programming, but also if you want to access resume books to fill particular roles for your companies or for your startups, please let us know. We'll be happy to provide those for you, because we have some fantastic engineering students who are trying to better connect with the local innovation ecosystem. And earlier this year, I was supposed to host the Chicago Venture Summit, which is the city's flagship VC conference. Obviously, it's postponed to 2021, and we're hoping to bring it back to really showcase early stage Chicago startups and connect them with investors from across the country. But we're very excited to announce a new initiative, Startup Chicago, which will be announced next month, which is going to be our new ongoing initiative to connect investors with early stage startups here in Chicago through a series of virtual events, and really focus on those who are getting ready for their next Series A or Series B. I'll share my LinkedIn info, but really glad to be here. And again, thank you, Current, for the opportunity to support this fantastic event.
Absolutely. And thank you so much, Evan. You can see why it's been such a great partnership for Current to work with ChicagoNEXT. We have been so incredibly proud to be part of this broader technology ecosystem. And I expect you will get to hear a lot more in detail coming up from Evan and also from Current as we think about how to build what we think of as the blue economy in Chicago, the people that are creating really important water technology, as well as all the people who demand it to, lessen their use of water in business, improve the way they manage it. So we'll be thinking a lot about this 2021 priority of growing Chicago's blue economy, kickstarting innovation and entrepreneurship within water tech. And so more to come. And with that, I'm very excited to turn it over to one of our Chicago-based companies. I'm sorry, actually, no, I'm not. I'm turning it over to Svetlana Taylor, Current's Technical Program Director, who has graciously offered to give us just a little bit of an overview of what we mean by digital water and why it matters so much to the work we're doing today. So Svetlana, over to you.
Thank you, Elena, and hello, everybody. It will be a quick presentation. So the water sector is making great strides in adopting digital technologies. And now we often hear terms such as digital water, smart water, intelligent water, and so on. But to set a context for the technologies and solutions that we'll hear about today, I'd like to step back and look at the terms that straddle across all different industries: digital revolution and digital transformation. Digital revolution, which is also called the fourth industrial revolution, started with the invention of a transistor in 1947, but it truly began transforming our lives with the advent of the internet in 1980, and has since changed almost every way we now interact with the outside world and vice versa. With this digital wave sweeping across the entire world and affecting literally everyone, businesses in all sectors started talking about digital transformation. So what is digital transformation? Next slide. The term digital transformation came into being around 2000s. There is no one single definition of digital transformation, so I'd like to offer the following definition. Digital transformation is a process of adoption of data-driven and digital technology-inspired frameworks that offer valuable insights and actions in support of business goals and organizational mission. The two important distinctions here is that it is not simply implementation of digital technologies or making the established processes work better, although both are parts of digital transformation. Many experts say that it is really about business transformation, which involves people and organizational processes and structures. Like any transformation, it must be driven by a problem or a need, and there is no shortage of this in the water sector. Next slide. So this slide lists the top 10 issues facing the water sector today. This is according to the American Water Works Association 2020 State of the Industry report. Significantly, half of these issues, including the top one, renewal and replacement of aging water and wastewater infrastructure, requires decision support And in today's world, decisions have to include a multitude of factors, including long-term sustainability and equity. Interestingly, the number 4 on this list, public understanding of the value of water systems and services, was number 1 for Current's partner who manages mostly small rural systems. Clearly, the solution to this particular issue requires a lot of communication and transparency. Next slide, please. So how can digital technologies help solve these issues? In the words of Jean Ross, who is a principal research scientist at the MIT Sloan School of Management and the MIT Center for Information Systems Research, this is where we need to get inspired by what these technologies have to offer. They offer transparency, both in communications with the customers, but also in evaluating how the business is doing, what works and what doesn't. Connectivity and connectedness. And with connectivity comes the ability to see what is happening in real time and receive early warnings. Some apply advanced analytics to gain insights into processes where current process models fall short or become too computationally expensive. In relation to the decision support, some can run multiple scenarios and analyze many factors in a fraction of the time it used to take. They're also able to examine patterns and predict a potential problem before it occurs. On the implementation side, they're quick to implement usually and require low upfront capital investment. At the same time, they're flexible and can be easily customized to different users. Next slide, please. All right, this is the inspirational slide. So all these technologies are a part of digital revolution because they're changing the way we do things. And they can also be a part of digital transformation. Utilities that started the process of digital transformation before the pandemic showed great resiliency in the face of it. And the extent of digital transformation can range from just making things easier to really getting it smart. So with this, I look forward to hearing about exciting technologies and solutions from our speakers today. Thank you. Elena, back to you.
Thanks so much, Svetlana. So you can see why we're so excited to end the year with an Innovator Showcase focused on this arena when there's been so much uncertainty, and we know we're all looking to 2021 with the same degree of scenario planning and contingencies and just worries about the different risks that we might be facing. This is why digital technology, with all of the different decision support tools, customer connectivity, everything Svetlana just mentioned, why it's so important for us today and why we're really excited to introduce our next speaker, one of our local Chicago companies, Chris Sosnowski from Waterly Software. So Chris, tell us about your solution.
Well, good morning, everyone. First, just a quick shout out and a thanks to Current and ChicagoNEXT. Very much appreciate your hosting and sponsoring this fun series. I've been able to be inspired by the different sessions we've had in the past with fellow water enthusiasts. I can say this has been some of the best packed in innovative content available during this kind of hard season we're in. So thank you guys. So before I jump in, I just want to take a quick second to thank water wastewater operators. I know there's tons of people we can thank during what we're dealing with right now, but these are the salt of the earth kind of people that we usually take for granted. And as far as I'm aware, water's kept on flowing, wastewater's kept on going as we've gone through all of this. So we appreciate what they do. So next slide, please. So I was fortunate enough to take this picture about a month and a half ago here, local municipality, Chicago based. And this is today's water data management. So this is real world, folks. I take pictures like this all the time. And if you just note the irony of the computer screen that is off and the clipboard that is effectively propped out. Now, zero of this was staged. This was just me visiting a plant for the first time to ask them, interestingly enough, about how they collect their data. So if you jump to the next slide, lest you think that after it gets off of that clipboard in front of the computer there, it ends up being digitally filed or captured. This is the reality. This is the file cabinet that is right next to the clipboard that you saw there. And this is what we affectionately call about 3 megabytes of data. However, it is not digitized, of course, at this point. So the simple truth is that about 85% of our water wastewater utilities in the US live like this today. So one of the things I heard Svetlana talk about was the need for technology to be simple and to be adoptable, that presenting technology to people does not mean we've been transformed by a digital revolution. So this is the problem that we faced. I spent the first 2 decades of my career serving these people and installing SCADA automation technology, and came to the quick conclusion that despite all the best tech that was out there, we were leaving a problem unaddressed. Next slide, please. So in a nutshell, what is Waterly? First, it's reporting. So there are regulatory reports that all of the 50,000 public water systems in the US have to submit every single month. We produce those reports for them, reducing their risk of non-compliance or forgetting or not having time to do those reports quickly. Second of all, we are an appliance too. We do have a smart IoT aspect of what we do to publish data from one side of the network into the cloud for them to aggregate that data. And most importantly, we're just a simple app. The app was actually made by operators. We actually interviewed over 200 people to ask them what they wanted this app to do, and that's how it was created. Next slide. So very quickly, this is what most operators see. They see something on their tablet or their smartphone from the field. If they have data being fed in automatically, they see a little teeny gray water drop, which means that data is being fed from an IoT sensor or something in their plant that's publishing that data to us. If they don't have that, then they can hand type in it. About 90% of Waterly's customers enter data into over 90% of the fields. So we are predominantly a replacement for the clipboard. It's very interesting because a lot of people are almost embarrassed if the public were to know how little technology they're using to create these regulatory reports and solve their problems. But the truth is, we're not going to fight them. We're just going to provide something that is simple, 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 with some really basic feedback for them. Next slide. So the output for operators is this is what they're all after, their holy grail of reporting. And that it varies state by state, but this is just a basic monthly operating report that produces operations data and finished water testing data for the state agencies. Next slide. So what Waterly's hoping for are achievable long game, and this is industry-wide. We want to integrate into this blue economy. I love the phrase. And so we think of things like notifying suppliers when it's time to order chemicals, allowing trusted partners to have access to live operations. We'll call it near live operations data in an environment that has nothing to do with SCADA or control of the water system. We look at realigning public water data. There's a lot of public data surrounding water, but really if you look to go check in on your public water system, you'd have to Google something called SDWIS, S-D-W-I-S. I'll drop a link into the chat window after I'm done. And then you'll find a very vintage 1990s bitmap image of the United States, in which at the very best, you might be able to find data that's about 6 months old. We want a much more simple, open water data portal, and maybe even consider someday asking public water utilities to flip their operations data public shortly after they publish it and review it. So the third thing we're looking to do for an achievable long game is to educate operators. There's a giant group of people that are looking, shall I say, hoping to retire in the next few years here. We hope to be able to reduce their non-revenue water, help them with chemical, help transition new employees. Next slide. And so wrapping up, Waterly is an app that's made for today's boots on the ground. We're really targeting the people that are putting this stuff together. We're not leaving out SCADA and all the investment has been made and is being invested in SCADA and IIoT for this industry. But there's roughly 65,000 water and wastewater utilities today that we can digitize in usually under 1 or 2 weeks. And there's not many technologies out there that are a low-cost investment that can see results in that quick of a time. We like to leverage all that existing smart infrastructure that it's out there. And I think if there's one thing I hope you hear today, if you want people to adopt technology, it has to be simple. We like to say that we're ridiculously simple. So with that, I'd love to take questions.
Fantastic. And we do have a couple. So I want to kick it off actually and just ask, what are some of the critical challenges to your business right now to scaling? Like what are some of the things that would be helpful for you in this next stage?
Challenges for us scaling wise is each state runs their drinking water and wastewater regulatory system, administers that based on federal standards. So to jump from state to state is a slight pivot. One of the wonderful things that we would love to see happen is a standardization across all 50 states legislatively to identify a common digital water model for capturing operational data like this. So that would be a great thing for us. I think one of the other big hurdles we have is just getting people that are not used to watching virtual seminars to watch virtual seminars and learn that there's technology available for them for about the same cost as the mayor's cell phone bill that they can adopt in a couple of days. So exposure for us is really important too.
Great. So there's a follow-up question from the chat. What are some of the other barriers to using this and other IoT fed technology? I mean, are there things like, you said the cost is really low. Are there other barriers, just risk aversion or slow adoption?
Yeah, I think for us, we typically see aversion to change. Our number one competitor is, quote, the way we've always done it, end quote. So guys are very comfortable and used to their 30-year-old clipboards, and to kind of get them to grab an iPad or a Android tablet or a Kindle Fire or something is a challenge too. So typically a lot of people don't like to change. And this is an industry that prizes reliability over efficiency. And I think that learning to pivot to appreciate efficiency alongside of reliability is going to be a challenge, I think, not only for Waterly, but on behalf of all the technologists here today, that people have to realize that they've got a greater stewardship than just providing reliable, safe water. They've got to provide a long-term vision too.
Yep. The operators themselves, another question from the chat, how are they reacting to the digital data platform? And do you interact with them to kind of help ease the transition once you've convinced the decision maker it's a good idea to use this?
Yeah, we like to kind of white glove the onboarding process. I still make a personal phone call to each of the customers that we pull on to ask them about it. And actually, we find the transition's pretty good. One of the things I get to brag on is Waterly doesn't have help documents for operators because they don't need it. If you're making a technology that's going to force people to sift through a 187-page PDF to figure out how to use your software, I think it's too complicated. So the biggest thing we try to help people with is just getting comfortable navigating a tablet. For many of them, it's the first time that they've used a tablet.
Got it. And I'm going to combine two questions about kind of concern for digital transformation taking over human jobs, right? And that kind of concern, do you experience that? And also, there's benefits to this sort of efficiency. How do you quantify those savings and communicate it in a way that's non-threatening?
Yeah, those are great questions. And I've taught some classes for the AWWA, and I always love to close the classes on technology, assuring people that there's a difference between the tasks that you have to do in your career. And so if you are a task-based person and you're worried that your career is going to vanish, I would not be worried at all. I think the careers for the people that are doing water and wastewater operations are more solid than ever. In fact, I've never met an water operator that's bored. So I think for them, this is not replacing labor, it's transferring labor from brawn to brains. So spend more time thinking about how to operate your system, figure out how to turn valves more often, preventative maintenance, things like that, that most everyone admits that they need to have time to do. So the second question was about quantifying savings. Waterly typically sees between 4 and 100 hours a month of saved labor, depending on the size of the utility. So it varies based on the size of the utility. We price based on the average daily flow, which makes it hopefully transferable for small and large utilities alike. But usually the savings is internal versus internal labor savings. But we also see over time that they're made better aware of things like electricity and chemical usage too, in ways that they hadn't before, because most of them are used to looking at their operations in a 1-month window, and we broaden that to be more of a database that they can look at over time.
Great. Thanks so much, Chris. We've got to move to the next presenter, but I'm loving this chat. There's tons of questions, so please feel free to start answering questions in the chat, and everybody in the chat, thanks and keep them coming. Now I'm really excited to go all the way across the ocean and introduce one of our very dear partners at IOSight. So we're going to hear from Guy Meiri, the head of business development at IOSight. Guy, please start your camera and unmute yourself.
Okay, I hope you can see me, you can hear me. So please confirm.
Perfect.
Great. Okay, so thank you very much. And I'm really excited to speak today. Usually I present the H2 Now Chicago at other conferences or events. And today I'm actually here and not going to talk about H2 Now Chicago, which is kind of like refreshing, but I feel it's almost like a second home in a way. Talking about it so much. So thank you very much for the current team for hosting me here. So what we do is data management and analytics for water. And we're kind of like also, we have some things in common with Waterly that we just heard from. So a lot of the challenges and value that we deliver, many of the questions have already been answered, I think, but we're gonna talk about some examples and maybe share some different perspectives as well. So please, next slide, please. So who we are and what we do. I say what we do, and we have over 100 installations worldwide. We've been operating for over 10 years, so we've gained a lot of experience, and we believe in engineering-driven solutions. So our team is combined of engineers, software developers, and algorithm experts or data scientists. And we started in Israel, basically took over the local market and started expanding internationally, focusing a lot on the US market. Next, please. So some of our kind of like clients or segments you can see here. So water and wastewater, you can see a picture that I took, which is quite familiar to you. When I was in Chicago, it's one of our clients, City of Chicago Water Department. So the water space, so water, wastewater treatment, and water utilities. And I'm going to talk about one of the examples later on. Desalination. In Israel, 80% of potable water comes from desalination. So all the desalination plants in Israel, 5 of them along the coastline, are using our system as well as the water authority. We also, watersheds and environment, so H2 Chicago, obviously, the Chicago River Water Quality Monitoring Project that we started in Israel with Mekoot at the Jordan River watershed protection. And I'm going to talk about it a little bit in a minute. Next, please. So when we look at our solution suite, we like to call it the Smart Water Suite. It's an integrated suite. So if you look at the center of it, is what we call the core, the data foundation. I think we've heard about it. It's very important to create a robust data foundation where all the data you collect from the different sources, online, offline, and extract the data, normalize, cleanse, model the data. This is like the foundation of everything. When you're done with that, you can talk about BI, reports, like we've seen, dashboards, event management and alerts, and all sorts of other things. And our core algorithm platform takes care of that. And sometimes I call the BI layer is like augmenting the human eye. Sometimes there's trends you cannot see. On the right-hand side, there are the expert modules like IOSight for water quality monitoring in rivers and watersheds, IWT and WWT for optimization of energy and chemicals in water treatment plants and wastewater treatment plants, and several others that I'm not going to focus on right now. So this is like what I call augmenting the human mind. It's applying all sorts of advanced analytic techniques, and they come on top of the core platform. Only when you have clean, well-treated data, you can do analytics. Otherwise, garbage in, garbage out. That's our approach, and that's our experience. Next, please. We've basically covered that. One thing I want to say is that one of our unique value propositions, one of the key ones is we've been delivering for over 10 years. So it's not about experimenting, checking, testing. It's been proven. So that's what I like. And there's a lot of water wisdom, water specific assets already embedded in our platform. Next, please. Some examples of our web and mobile dashboards you can see here. So the top ones are for water quality monitoring in Jordan River, and the bottom one you can see water municipality, water system in California. Next, please. And we have a rule-based event management system. You can define rules, different types of rules, and then manage events that are triggered by those rules. Next, please. A map view, which is important. You can see here on the left-hand side, a map out of the Chicago River project, the H2 Chicago, and on the right-hand side, the Jordan River project. Next, please. And this is maybe the more interesting part, which is the algorithm-based expert modules, the right-hand side of the diagram that I showed earlier. IOSight for water quality monitoring in rivers and watersheds. It's an anomaly detection solution, basically helped eliminate 95% of false alerts in that case. IWT, I mentioned earlier. Next, please. And the other ones are INET for non-revenue water in district meter areas, IOptiNet for water supply system optimization, and iDetect for early fault detection, machine failure, quality exception, flow, and other types of anomalies. Next, please. I want to talk about two projects, maybe. That's what I have time. First one is very interesting because it's a recent one we've done in California. We've delivered a system to Las Virgenes Municipal Water District in Southern California. And the nice story here is that we started in March. We were supposed to go there, and obviously we got hit by COVID. So we started, okay, we said, and they said, let's start with remote meetings. And we ended up delivering the entire project remotely. So covering the reservoir filtration plant distribution system. They were a great team. It's all about people at the end of the day. We wouldn't have been able to do that without their kind of like enthusiasm and support and collaboration and really championship of this project. So that was an amazing experience. And just for that perspective, I think things can be done during COVID remotely, 10 hours away from us. So in California. Next, please. The next one, maybe the final slide that I will talk about, is the Jordan River water quality monitoring project, the iShed, which is kind of like the inspiration in a way, and then kind of like we use a lot of that in the H2 Chicago project. It's been operational since 2017, actively protecting, monitoring in real time the water quality in the Jordan River and the Sea of Galilee, which are the only major surface water source in Israel, a strategic asset in Israel. It's a project which has national security implications, and therefore the accuracy and reliability are highly important. We really help to reduce 95% of what previously used to be false alerts for various reasons, and also have an algorithm for downstream propagation calculations and event management. On the left-hand side, you can see the specific kind of like gauges for water quality indicators like pH, redox, AC, and turbidity. On the right-hand side, you can see the water quality index, which is the outcome of the iShed algorithm that can really tell you if there is a real event or not a real event. And the top picture, you can see the map view, as well as on the right-hand side of it, the contamination downstream calculations. So I think I'm probably out of time right now. I have several more examples, but I think
that was fantastic. Thank you. No, thank you for your presentation. I actually have a question right here in the chat from Chris. In what areas do you see customers typically see the most payback or risk reduction with IOSight technologies?
Could you repeat that, please?
Yeah, sure. In what areas do customers typically see the most payback or risk reduction with IOSight technology?
I mean, you saw, if you can go back to the iShed example, to the Jordan River one, then obviously water quality in surface water, the ROI is clear. It's not just cost, it's health, public health, it's environmental protection. That's clear. You know, it's like especially if it's source water. In the Chicago River example, it's not drinking water, but in other cases it is drinking water, so it's clear. Okay. And the monetary savings are huge, but beyond that, it's public health. When it comes to optimization of, let's say, energy or chemicals in water treatment plants or wastewater treatment plants, then it can go all the way up to maybe 10% of those cost bases. And And in desalination plants, it's, for example, energy is a huge portion of the expenses. So that's pretty clear. But beyond everything, sometimes you just see stuff that otherwise you couldn't have seen, right? So energy reduction, cost reduction, chemical cost reduction, water quality improvement. Obviously, I mean, the implications of, even for water treatment plants, to make sure that, you know, there's no deviation. I mean, beyond the reporting that they do, there's the ongoing monitoring of that is critical. I can give you tons of examples for that if we have time. So.
And thank you, Guy. And then the next question here is from Lev. What in-house capabilities do customers need to operate IOSight effectively?
It's a very easy to use solution. So once we do the first installation, normally we need like some sort of a champion, somebody who's kind of like, but he doesn't have to be like a sophisticated IT guy. I just saw yesterday one of our largest clients in Israel, the Shafdan wastewater treatment plant. I just saw some of the dashboards that they created without us. It was amazing to me. It was nicer than the ones that we do, I think. Because why? Because they understand not the software, but they understand their system. Once you understand your system, you're an engineer, you're a water professional, you understand what you have there, then you can do whatever you want with it, basically. So, right, so you need to understand your own system, water system, wastewater system, and then it's just a tool in your hands. So.
Fantastic. Awesome. Guy, thank you so much for being here today and for the presentation. For anybody who needs Guy's contact info, it's right here on the last slide. And we'll now continue to our next presenter. And so it's my pleasure to introduce Patrick Kiely, CEO of SENTRY. He'll begin his next presentation.
Thank you, Ben. This is fantastic. All right. So thanks, folks. My name is Dr. Pat Kiely, and I'm the CEO of SENTRY. Next slide. Okay, so in terms of the problem statement, and looking to Waterly, I just love that platform. But you know, there's further problem statements. So in terms of how do operators, for example, of water wastewater treatment facilities actually monitor the performance of their infrastructure? I've just highlighted here on the image, there's a chap here on the bottom right who's taking a manual wastewater grab sample. Facilities might do this Monday to Friday at 9 a.m. typically. And that information, that single data point, is basically useless. It's useless to anyone who's trying to understand their process, because there's 24 hours in a day and wastewater is dynamic. There's diurnal flows, there's potential industrial clients discharging big slugs of organic carbon or something toxic, acutely toxic into your wastewater streams. There's heavy rains impacting inflow and infiltration, and that's impacting your biomass. So having someone physically take one sample, you know, 5 days a week at 9 o'clock doesn't help anyone. And then on the top right, what I have is just pictures of your traditional real-time light-based sensors. So these sensors work by sending a light signal through a glass slide into a wastewater environment. And that refraction basically tells a correlation, provides a correlation to what's in the wastewater. The problem is biofilm grows on everything in a water environment. And within a few days, typically these sensors begin to drift because biofilm begins to grow on the glass slide, and that sensor information becomes not very valuable, and then it's not trusted by operators. So, and then the key thing is, if you're operating a wastewater treatment facility, for example, and if you have these changing events, if you have this biological imbalance, you're going to be impacted on your effluent, and the costs associated with that can be certainly prohibitive. Next slide. So in terms of what we do at SENTRY, we've developed a whole new way of monitoring water quality. Instead of trying to remove biofilm from the sensor, we actually leverage biofilm. So in the middle here, what you can see is the physical sensor itself. So it's really simple. It looks and feels kind of like a DO probe or a pH probe, except at the bottom, what we have are two conductive surfaces. We apply a very small voltage across the surfaces. And what that does in effect is it just lets the normally occurring bacteria that are already present in the wastewater grow on that surface and use it as an electron sink. Making it really simple, it basically functions like a heart rate monitor or a Fitbit, or if you're technical, like a respirometer or a reverse respirometer for the biomass. So we place these sensors then in the wastewater treatment process, right the way from a wastewater collection system to a primary clarifier, downstream in your process, and we provide this information as a real-time signal to a dashboard for operators to simply view how the biology in their plant is performing. And really simply, we set these calibration alerts on the dashboard. And if the signal spikes up into the high end, it's indicative of too much food or abnormal amounts of food for your biomass. And if the signal drops to the low alert signal, it's indicative of either something acutely toxic in your wastewater environment, or there just is no food available left for your biomass to consume. Next slide. So just because we developed a new type of sensor doesn't stand for much. It's all about value, and it's all about documenting value for your clients. So we started installing commercial systems 3 years ago, almost exactly. When we started, we actually started in the anaerobic digestion space because toxicity and process upset for high rate ADs is a real issue. But what we figured out very soon, just after communicating the technology to various clients, potential clients, we found that there was a lot of demand for understanding process performance also in the municipal space and also through aerobic wastewater treatment plants. So most of our installations at this stage, for example, are actually in influent primary clarifiers. In this location, we can profile exactly what's coming into a wastewater treatment plant. We can perhaps even provide a feed-forward signal to the aeration basin, providing better DO set points and savings on aeration for that. But also from that primary clarifier location, we can quantify the exact impact of diurnal load changes, toxicity in the wastewater, profiling resiliency of the treatment process, the impact of inflow and infiltration into your process. So we can get a lot of that information from one sensor located in the primary clarifier. And the really cool thing here for us with this sensor is that it's biofilm based, so the maintenance is very minimal. We require once every 3 months that the operators simply do a visual inspection of the sensor to make sure there's nothing, abiotic on the sensor. But other than that, there's no cleaning. We have sensors installed now for over 3 years that have had basically zero maintenance. So once they're in the wastewater, the biofilm grows on it and it provides an appropriate signal. Next slide. So this is where we work. We're headquartered in Canada, but we work across North America. I've just picked out San Fran PUC was one of our first clients in North America, and we've been working with them for nearly 3 years now. In Europe, one of our major clients is POX. So POX operate over 2,000, or they've designed, built and installed over 2,000 high rate anaerobic digesters globally. We work with Kurita out in Japan, and then Singapore PUB is a fantastic client of ours where we have over 10 sensor systems deployed throughout their wastewater collection network, but also at their wastewater treatment facilities. So working through the collection system to identify and quantify the impact of key industrial dischargers, and then profiling the impact of those potential discharge events on the performance of biology at the wastewater treatment facility. Next slide. So I'll leave this up here. I mean, our business plan and go-to-market strategy is quite different, and we don't sell equipment typically. We understand it's a new metric, so offering what we do as a service tends to be, it offers a lower barrier for our customers. So this is what we typically provide for new clients: a control panel, 2 sensors, and an online dashboard. So we provide all the equipment. The sensors are installed in a couple of hours, really simple, just like a DO. If you can install a DO probe, you can install one of these sensors, and then everything is end to end. So once you install them and plug in the control panel, the information is going straight to the cloud or the dashboard already. So it's basically like having kind of an always on alarm system for your treatment process. And then once every 6 months, and then every 12 months after that, we provide a statistical report for our clients that not only quantifies all of the events, details when they happened, but also provides suggestions on further savings at the facility. So aeration optimization would be a really key one for us. Supplemental carbon dosing is a really obvious one for us as well, or co-digestion of anaerobic digesters is a really nice one for us. And with that, I think I'll pause and answer any questions.
Fantastic. Thanks so much for that presentation, Pat. That's terrific. And we've already got questions in the chat. One from Chris: do you have examples or case studies you can link to where this has saved a certain percentage of energy because of this feed-forward aeration process control?
Yep, fantastic. So we actually have published case studies from Wessex Water in the UK. We're also working with United Utilities on projects like that. We're working with San Fran PUC. So if anyone wants to reach out to me, the next slide actually should have my contact information. People can take a screen grab of that, send me an email, and I'll follow up with all of those case studies. Yeah. And a bunch of them are on our website as well. So SENTRY Water Tech, you can scroll down and find a bunch of cases.
Great, fantastic. I was just going to ask for the case study link, but that's terrific. And then a follow-up question, how does it correlate with CBOD? What's the correlation?
Fantastic. So this is the interesting thing. So what we're measuring is a rate at which the biofilm is consuming carbon. So if you're measuring BOD, it's going to correlate very closely to CBOD until it doesn't. And those periods of time where it doesn't correlate to your BOD are the moments where you're most interested, because that's when there's something in the wastewater inhibiting your biomass and stopping it from actually doing its work. And to be honest, BOD measurement is it's not a very good measurement if you're trying to understand your process anyway. What you really want to understand is your biomass actually doing its work? Is it actually consuming carbon? And to what degree is it doing that? And identifying the periods when it can't consume carbon or when it's consuming more carbon than normal, that's what you need to know about.
Great. And then I actually have a question about your supply chain. So you're providing all of this hardware, all the sensors, right? Has there been any hiccups in that, challenges with getting particular parts of that process, especially with, you know, all the COVID-19 disruptions this year, or no, that's just been,
no, we're very lucky. We actually, day one, we worked with an industrial designer to design the sensor. This chap wasn't familiar with the water industry, so came at it from a completely new perspective. All of the components are stock, like all of our sensors are stock PVC. All of the components are kind of stock parts for the most thing. I mean, we do have specificity on the electronics, but if you look at our sensor, you're just like, dear God, that's heavy and that's like robust, and that is not, you know, it's just, there's nothing fancy about it, so we don't have those issues.
Yeah, that's fantastic. Pat, thanks so much. This was a really terrific presentation. We're so happy to have you as a partner. And now we're going to bring it home back to Chicago. And I'd love to have Lev Goldberg, please unmute yourself and start your video. And we're going to hear from Aquify, an Exelon company. Lev?
Great. Thank you very much, Elena. Thank you very much to the whole current team. I've been watching a lot of the Innovator Showcase Series videos over the last few weeks, and it's just a tremendous job you guys have done, and a tremendous mission to bring technology and from across the world to Chicago to Illinois, and then back out to all listeners all over the place. And I did get a chance to look at some of those that are participating today and notice a few names from places that are outside of Chicago, so that's really fantastic to watch. My name is Lev Goldberg. I am the CEO and co-founder of Aquify. Aquify is a 24/7 monitoring and analytics service that helps water utilities identify leaks, find leaks, prevent leaks from happening, all without having to require a single dollar spent from their capital budget or leveraging or utilizing a single data analyst. The problem that we're dealing with today is really the pipes, and next slide there, please, is the aging pipes underground, the 240,000 water main breaks that happen every year that leak 2.1 trillion gallons of water, costing our utilities across the US $2 billion. And the problem itself, as most people on this phone call meeting probably know, is that the problem is getting worse, not better. 27% increase in water main breaks over the last 6 years alone. Next slide. Today, utilities are basically utilizing two methodologies to deal with these aging infrastructure. One, obviously replacing pipe, rehabilitating pipe, which is a fantastic structural solution. However, it's extraordinarily expensive. It's very, very disruptive, and you can only do a small percentage of your system at any given time. So what happens to the other 99% of your system that's leaking water? Well, there's leak detection surveys and inline pipe inspections. These are easily more deployable, much more affordable, but similar to what Patrick was saying, systems are dynamic. Leaks happen all of the time. And a leak that happens the day after the survey is conducted could go undetected for months, if not longer, costing utilities tens or hundreds of thousands of dollars in water loss. Surveys, in fact, are snapshots. What utilities need today is continuous visibility. With continuous visibility, utilities will know when leaks happen so they can prevent this costly runtime from happening. They'll know where leaks are happening so they can address their teams and the resources to the specific areas of the network that are leaking, that are vulnerable, and they'll know why leaks are happening. With enough data, you can start to correlate reasons why a leak might be occurring on a particular part of the pipe, perhaps due to water transients that are happening from a hydrant being closed incorrectly. Aquify, next. makes continuous visibility possible for any water utility of any size. And here's how we do it. We install bidirectional flow and pressure sensors at strategic locations across a water utility's distribution network. And what happens then is that essentially creates hydraulically distinct zones, taking this one large network and breaking it out into smaller zones, or DMAs, district meter areas as they're called. Aquify then monitors each zone for utilizing our machine learning algorithms to find system anomalies that are such as leaks, water theft, low pressure events, and more. Next slide. And we're able to deliver this as a service for customers and make it accessible for utilities. So it's one thing to have technology, it's another thing to actually have it accessible and available for utilities, especially those mid-sized and smaller utilities that may not have control rooms, may not have operators on hand who are familiar with and can utilize the data and the software and the systems and the inflow of data that's currently coming from all our different systems. So what we do is the data from our sensors. Aquify owns these sensors. We'll install those sensors and maintain those sensors for the length of the contract. The data from those sensors and the data from the SCADA assets from the utility themselves all goes up to the analytic software. The software compares the actual consumption, the actual flow, the actual pressure to predictive models and identify system events. The software itself that we have is available to our customers, to the utilities. They have total enterprise access to the software. But because many utilities have told us, even if they had access to the software, they still wouldn't have the people who can actually sit and watch the software, who can actually sit and manage the data and the analytics of the data and understand what's happening on their system. We actually provide that as well. The way we do that is through our Network Operations Control Center in Baltimore, Exelon's Network Operations Control Center, that already monitors Exelon's renewable energy fleet. So the same folks that are sitting in a secure, physical secure and cyber secure environment, watching critical infrastructure assets, are also watching our water utilities distribution systems, and they're monitoring the systems 24/7. They're giving analytics and ad hoc analysis to their system. So what our customers get is the software itself. So they get the professional software, they get the software itself. They get the sensors and the sensor maintenance. They get the people, they get 24/7 operations monitoring and analytics, and you get the cyber secure network all wrapped up as a professional service. So there's no need for capital costs. There's no need for your staff. If you have staff, they can operate and manage the software itself. That's fantastic. But we basically, our goal is to meet customers where they are in their digital journey, whether they have people or they don't have people. Next slide. And so is there an ROI at the end of the rainbow? There certainly is. A typical customer of around 10,000 connections with 140 miles of main. This scenario will save upward of $250,000 a year, in addition to a lot of other benefits that can be accrued simply by understanding what's happening in their system in real time. And next. And just to kind of wrap it up, is a little case study that happened not too long ago and not too far away from where we are today. In Buffalo Grove, just over Labor Day weekend here, Sunday morning around 1 o'clock in the morning, our Network Operations Control Center noticed that on the system, the predicted flow and the actual flow in the east zone, one of the zones in Buffalo Grove, Illinois, just northwest of Chicago, was starting to deviate. They did some initial triage. They identified that this was in fact an event worthy of alerting the customer to, called the customer, told them what was going on, and told them essentially where in that zone to go look for that leak. The customer went out, indeed found a leak. What they found was a leak that was leaking 640 gallons per minute. That was happening right there on, if you look on the right side of that slide, that was happening in the backside parking lot off of a small lateral of an unoccupied building in an industrial park, just off of, just a few feet off of a water body. This is a leak that, just because of the fact that it was unoccupied, it was behind the building, right next to the water, easily could have gone unnoticed for a very, very, very long time without anybody noticing. Probably too small for that SCADA system to pick up, too small and out of the way for anybody to actually notice what was going on. So that leak that would have been losing about 1 million gallons a day was found and fixed within a few hours. The customer was very happy, understood the value of what we're trying to do, which is really be that augmented staff of a utility. Utilities today have to do more with less, and we're leveraging Exelon's smart grid leadership, smart grid expertise, and Exelon's embedded resources that we already have that for the betterment and for the enablement of water utilities of all sizes. And I'll stop for there.
Well, thank you so much for being here today and for the presentation. The one quick question I have from Nicole is, she saw a line item in your presentation dealing with water theft. Can you explain that more for the audience, what water theft is?
Sure, it's one of those things that most people don't think happens, but it definitely happens. As a matter of fact, another example that we found with one of our customers, we noticed that there were spikes that were occurring on a regular basis over the course of a few weeks at about the same time of the day, of water flow being pulled at some of the zones of one of our systems. We alerted the customer to that. They went out to that area and noticed that there was an asphalt contractor that was hooking up to the hydrants, pulling water to and utilizing that water without any authorization, without any metering. This is the type of thing that simply happens, fairly frequently, we believe. But there's very few ways that you could really detect it without somebody actually sitting and watching the system. And again, that's also about having not just the data, but actually having the eyeballs, actually having what we call, there's machine intelligence and there's also human intelligence. So we believe bringing them together will help uncover these types of things.
Got it. Thank you for that. And then the next question is from Chris. It says here, Lev, you guys have great data on COVID's impact on residential versus industrial/commercial water demand. Can you share some insights about that data?
Oh, sure. So, one of the interesting things was right at the very beginning of COVID, sometime around, I believe it was around April or so. One of their customers was asking the question around, what was happening is at the village staff and board level, there was a lot of concern about how much revenue was going to be coming in to support the water utilities based on COVID. Commercial, users and industrial users obviously weren't working at all. So there was really quite a bit of concern about what this was going to do to their budget. So we took a look at the consumption patterns and the usage patterns, predictive as well as the actual patterns for the commercial, industrial, and residential for this particular customer. We're able to identify that because the residential load was increased and because of the rates for the residential customers were more, that assuming everybody was paying their bills, that the utilities itself should be able to manage through COVID crisis, at least the initial sort of triage area time when there was very little industrial and commercial demand. We'll be able to manage through it without any significant hit to their budget. So that was just one of the areas that we've been able to watch and monitor.
Got it. Thank you. And the last question here is from Rain. Has the transition to PVC pipe from cast iron over recent decades showed any improvement in terms of resistance?
Yeah.
Occur at connection regardless of pipe material?
Can you just repeat the last part of the question?
The last part is, do more leaks still occur at connections regardless of pipe material?
Leaks definitely occur. There's no doubt that that PVC, the data that I understand from PVC is that fewer leaks will generally speaking occur, especially over time. But leaks do occur on PVC, and one of the challenges that standard acoustical leak survey companies have is that those technologies do not pick up leaks at the same frequency and rate of metallic pipe. You'd have to do many more instances of listening, along the pipe. Just sound doesn't carry. So, which is why we also believe that it's really important that you can measure if you measure flow, you measure pressure, especially flow along a system, regardless of the type of the piping that you have, you'll be able to really get a sense for how much water is actually being lost through that system.
Great. Awesome. Thank you. Lev, thank you so much for joining us today. That was
thank you.
Presentation. And If anybody else has any additional questions for Lev, please feel free to add it in the chat.
Great. Thank you to all of our presenters. It was really meaningful for us to kind of end the year thinking about how to reduce uncertainty, reduce risk, reduce waste, and reduce cost, and really try to think about how to manage the uncertainty that we're all facing in these times today, and are so important to figuring out better and smarter ways of managing to better, cleaner, safer water. So thank you to everyone for the great work that you're doing. Please follow up with any of our presenters if you have questions for them and can continue the conversation. And then please follow Current. We've got upcoming events, a couple more to close out 2020. We'll be presenting on the opportunity to join Current as a corporate partnership, and you can learn about our new partnership with a startup called Halo that actually connects, it's an open innovation platform that connects researchers and industry with startups and promising solutions. And so we're really excited to share more about that partnership. And then we've got our next installment of the Third Coast Water Seminar Series coming up, which will feature Dr. Megan Mauder from Stanford talking about desalination for a circular water economy. So those are going to be our final two events to close out 2020. And let me just close out by saying I am so grateful to our team, George Brigandy and Svetlana Taylor, for making this possible, to Eben Kriakos for being such a terrific partner with ChicagoNEXT on the Innovator Showcase Series this year, and to all of you. You're the innovation community that's powering water problem solving here in Chicago, globally, around the world. This is a truly shared problem, and I hope that we can look forward to working with all of you in 2021. Have a wonderful Thanksgiving, find joy in unexpected places, be grateful, and we just look forward to seeing you soon on another event. Thanks so much, everyone. Take care.